All right, guys, welcome back. This is going to be kind of not a review, but expounding upon of 9.6. What I'm going to do here is I'm just going to do two examples from the homework problems. I wanted to provide more examples of this process of factoring that we are working through. If you are in quarantine right now, what you should have been doing for today is there's some extra problems on Schoology for 9.6. Go ahead and give those a shot, as well as redoing some of your 9.6 homework. If you maybe checked those with the key, got some wrong, and weren't really sure what to do. After you watch this video and take notes, maybe you'll feel a little better. Hopefully you'll feel a little better. And you can go back and retry some of those homework problems. Then once you're done with those, to get some extra practice, work on that 9.6 extra practice posted on Schoology. Again, let me know if you need help with any of those problems. Similar to what I'm doing here, I can make you a little video instruction showing you how to solve the problems. So after you watch this, be really diligent. If you're still struggling, email me, let me know so I can help you. Okay, so the process we're doing here is we are looking to factor this trinomial. And I notice offhand that there is a number in front of my first term. So what am I going to do first? Well, your first step is to multiply that coefficient of the first term by the last term, okay, which is a constant. So I'm going to do 13 times negative 5. And when I do that in my calculator, 13 times negative 5, I get negative 65. Negative 65. So what I'm going to do here is I'm going to find the factors of negative 65. Okay, I'm going to find all the factors, keeping in mind that I want to find the ones that will give me positive 8. Okay, so I've got 1 and 65. 2 isn't divisible by 65. 3 isn't. 4 isn't. 5 is divisible by 65, 13. 6 is not, 7 isn't, 8 isn't, 9 isn't, 10 isn't, 11 is not, and 12 is not. So we just have, and at that point we'd hit 13, so we've made all the factors we can. So not a lot of options here, despite this being a bigger number. And now I have to determine which factor pair and what signs to use. So at this point, let's focus on the signs. We always have 4 different options for signs. We could have positive, 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 negative, negative, positive, or negative, negative. And you can see I'm drawing multiplication signs between them because the first thing I want to look at is what do I need to multiply together sign-wise to get negative 65? Well, I have to multiply to get a negative. And a negative times a negative will give me a positive, and a positive times a positive will give me a positive. So we can rule those signs out. So either my first factor needs to be positive and my second one is negative, or my first one is negative and my second one is positive. Either way, my factors are going to have opposite signs. So now that I've ruled out 2 of them, now I'm going to go look at the sign in front of my middle term, my 8p. I notice it's a positive sign, so how can I make positive 8? Well, 1 and 65 won't work, but 13 and 5 will if I'm careful. I need positive 8, so that means the 5 has to be negative and the 13 is positive. If maybe you sat there and said, hey, the 13 should be negative and the 5 should be positive, you're close, but that'll give you negative 8. And we want positive 8. So I determined that negative 5 and positive 13 is the route to go. So what I do now is I do what's called splitting the middle, where I replace my middle term with my 2 factors. Now, it doesn't matter the order you write the factors in, just make sure they have a p and make sure they have the appropriate sign. So I split the middle with my 2 factors. Next, I build that wall that we've talked about in class, right? We're going to put my first 2 terms on the left side of the wall, my second 2 terms on the right side of the wall. Signs included. And we're going to factor out greatest common factors. Now I look at this and I see 13p squared and 5p. What do they have in common? A p. So I take a p out and I have 13p minus 5. And again, I'm thinking in my brain now, how can I get the other parentheses to match 13p minus 5? Ideally, what happens is if I take out a greatest common factor from what's on the right side of the wall, I should end up with the same thing in parentheses. Well, if we look at 13p minus 5 offhand, it doesn't look like there are any factors. Greatest common factor. You see, there's no number that 13 and 5 are both divisible by, and they both don't have a p. So when in doubt, when you don't have a greatest factor to factor out on one side of the wall, we can always factor out a positive 1. Why? Well, a couple things here. One, every number is divisible, or every term will always be divisible by 1. So every term has a positive 1 as a factor. Number 2, by factoring out a 1, I don't change the 13p minus 5, which keeps my parentheses matching. So once you factored out the greatest common factor on each side of the wall, bring the whole band back together and make sure whatever you factored out on the right side of the wall, that sign of whatever you factored, here I factored out a positive 1, make sure that sign goes right in between your two terms as we bring this all back together. Okay, if I had factored out a negative 4, I would have a minus 4 and then the parentheses. So at this point, your last step, we look at what we have written here. We go, what do the two terms have in common? Okay, what does this term have in common with this term? Well, they both have a 13p minus 5, so go ahead and factor that guy out. Now, you have learned in previous instruction, as well as seen above here, when we factor something out, it means we are dividing by it. So what's essentially happening here is I have p times 13p minus 5, and we are dividing by 13p minus 5. Now, you might go, holy cow, I don't know how to do that. Well, I think you do. You just don't know it. Think about how you would solve 2 times 3 divided by 3. Well, 2 times 3 is 6. 6 divided by 3 is 2. Now, what do you notice here? Well, what you notice is that you could have just canceled the 3's. And this is a math rule that's true. Anytime you have several things multiplied together and you are dividing by one of those things will cancel out. Okay? Anytime you have several items multiplied together and you have one of the items on the top and the bottom are the same, they will cancel. So when I look at p times 13p minus 5 divided by 13p minus 5, I can cancel out the 13p minus 5s using that same logic, and I'm left with just p. So practically, whenever you're factoring out the 13p minus 5, whatever's being multiplied by it is just what's left. So when I look at the second term, 1 times 13p minus 5, I'm just left with 1. And this will be my answer. You want to check your work, of course, go ahead and distribute out these binomials like we've been doing, and you will find that indeed you will get the same trinomial that we started with. Okay? So this is kind of our factoring process, splitting the middle, doing some grouping, finding greatest common factors, all of that good stuff. When we have a coefficient in front of our first term that is not a 1. Okay, let's do another example. 21h squared plus 72h minus 48. Well, in your brain, you're probably going, all right, multiply the coefficient of the first term and the last term. 21 times negative 48, and holy cow, negative 1,008. And you're going, oh my gosh, I'm going to be up all night finding the factors of that. You are correct. You will be up all night finding all the factors of that. But you can do it and you can solve it that way. But there's an easier way. If you don't have this down in your notes already, make a little note here. We always want to find a greatest, or not find, we always want to see if we can factor out a greatest common factor first. Always look at when you're factoring trinomials and see if you can factor out a greatest common factor from each term. Okay? If I look back at my first problem, there was no GCF. No number except for 1 divides 9, or can you divide by 13, 8, and 5 and get a whole number? But that's not true for 21, 72, and 48. So let's see. Let's see what that GCF could be, or even if there is one. Well, if I divide 21 by 2, I'm not going to get a whole number, so 2 is out. If I divide 21 by 3, hey, I know that's 7. That's a whole number. What about 72 divided by 3? Try that in the calculator since it's a little bigger number. Hey, we get 24. That's another whole number. Let's see if third time's the charm. 48 divided by 3. And you get 16, another whole number, which means all of these terms, or all these coefficients, are divisible by 3. Therefore, I could factor out a 3. Now, be careful. We always want to look for the greatest common factor. So I'm not going to stop at 3. I'm just going to run through a couple more numbers in my brain to see if there's anything bigger that maybe will factor out. Well, 21 is not divisible by 4, 5, or 6. It is divisible by 7, but 72 is not. 21 isn't divisible by 8. It's not divisible by 9. And so at this point, I'm safe staying at 3. Okay? It'll present itself here if I didn't factor out a greatest common factor. If 3 was not the greatest common factor, it'll show itself here when I factor out the 3, because you'll see that I can factor out more. But let's just work with 3 for now. So if I factor out a 3 from each term, that means I'm dividing each coefficient by 3. So I get 7h squared plus 24h minus 16. And again, to make sure I divided out the greatest common factor, 7, 24, and 16, there is no factor that, except for 1, that divides by those numbers and gives us a whole number. So I factored out the greatest common factor. Now, what I'm going to do at this point is I'm going to take the 3 and I'm going to pause the 3 for a second. You see, the 3 is an important part of our answer. And a lot of students tend to forget about the 3 when they factor it out, or whatever greatest common factor you factor out. We don't want to forget about it, but it's going to look kind of messy if we just keep bringing it down in each step that we go through the process. And I don't want you to make the other mistake, which is accidentally multiplying the 3 back in. No, we're factoring here. We want to get everything out, not put anything back in. So what I would recommend you do is draw an arrow on your paper pointing the 3 to the answer, because the 3 is a valuable part of our answer. It's going to be multiplied by our factors. And so we don't want to forget about it, which is why we draw the arrow, but we also draw the arrow so that we don't accidentally multiply the 3 back in as we're solving this and get ourselves confused. So the 3 we're temporarily going to forget about. And now I'm just going to try and factor the simpler trinomial, 7h squared plus 24h minus 16. Again, your disclaimer, if you chose not to factor out the 3, if you're like, this is confusing, I'd rather just find the factors of 1,008, which is 21 times negative 48, and be done with it, you will get the same answer either way. So now if I'm going to factor 7h squared plus 24h minus 16, I need to go through the process again. 7 times negative 16. And I get a more manageable number to work with here. Though it's still somewhat big. I'm going to multiply, or I'm going to find the factors of negative 112. And so I start with 1 and 112. And I know, obviously, I'm keeping in mind, how can I get positive 24? Obviously, 1 and 112 will not work. 112 divided by 2, 2 and 56. Again, that will not give me 24. 112 is not divisible by 3. 4 and 28. Hey, what do you know? That might give me 24. I see it, but before I say A-OK, which is why I'm putting a question mark here, I need to go ahead and make sure that the signs line up as well. Remember, there are 2 parts to the signs. First, deal with the multiplication. The 7 times negative 16 gave us a negative 112. Well, our 4 options for signs are as follows. And I need to get a negative 112 via multiplication. So I can't have a positive times a positive or a negative times a negative, which means my factors have to have opposite signs. Now I look to the middle term, which is positive 24. How am I going to end up with positive 24 if one of these, the 4 and the 28, has to be negative and one has to be positive? Well, to get positive 24, I need negative 4 and positive 28. Okay, so again, use the signs, both first the multiplication, then the sign of your middle term when we're looking at the addition to determine your factors. So now I split the middle. Again, let me pause here. If you need help with the signs, shoot me an email and let me know. I'll help you out and give you some more practice with that. Minus 4h plus 28h minus 16. And splitting the middle. At this point, build my wall. 7h squared minus 4h and 28h minus 16. I go ahead, it says 8h, not 4h. I notice I can factor an h out of these, which means I need to do 7h squared divided by h, giving me 7h. Minus 4h squared divided by h is just minus 4. On the other side of the wall, I can factor out a 2 for sure. But if I factor out a 2, I'm going to get 2 on the outside, and then 14h minus 8, which will not give me a matching parentheses. So I keep going. I could factor out a 4, which is the greatest common factor, right? We're looking for the greatest common factor, not just any factor. So if I factor out a 4 as opposed to a 2, 28h divided by 4 gives me 7h. And negative 16 divided by 4 gives me minus 4. What do you know? My parentheses line up. Again, bring the band back together. This sign in the middle of these parentheses, the sign separating these terms, is whatever matches the sign of what I factored out. I factored out a positive 4. It's going to be plus 4. It's pretty messy. And so we get 7h minus 4. And at this point, what do these terms have in common? They have a 7h minus 4. And so I do 7h minus 4, factor that out. From each of these terms, what am I left with? H plus 4. And again, if you're unsure, wait, you factored out a 7h, goodness, written that twice. He factored out a 7h minus 4 from each term. How did he end up with the h plus 4? Rewind the video to the previous example and you can see why. Okay, so that would be my answer. Again, now you've seen 2 examples of, again, factoring trinomials when that first term has a coefficient that's not 1, okay, including an example here where we had to factor out a number at the beginning. We factored out a greatest common factor at the beginning, then did our factoring process, which, by the way, we cannot forget about. See that sneaky little red arrow in the upper left-hand corner? That's reminding me what has to be out front? My 3. Can't forget about my 3. At the very beginning, I factored out a 3. So that 3 is going to be multiplied, just as it was by the whole trinomial up there. If I'm rewriting the trinomial as a product of 2 factors, then that 3 will be multiplied by those 2 factors. That right there, you can see I almost forgot it, is why we draw the arrow. Okay? So A, we had one example of just factoring a trinomial where the first term didn't have a coefficient of 1. And then B, we had an example where it was a little more complicated. We factored out a greatest common factor, then factored a trinomial, where again the coefficient in front of the first term wasn't 1, and we solved them both. If you need help with these, let me know. If you are, say, working in the 9.6 extra practice or the 9.6 homework, and you hit a problem and you don't know how to solve it, shoot me an email. I'll make a little video showing you how to solve it, and I'll happily help you out. Thanks for watching, guys, and good luck.